Hi everyone, this is Pratima Naik. Today I'll discuss some Mathematics Olympiad questions with solution based on Chinese remainder theorem. A woman was carrying a basket of eggs. A passerby bumped her and she dropped the basket and all the eggs broke. Passerby asked her number of eggs to pay her. Woman replied, I don't remember exactly, but I do recall that if counted in pairs, one will remain. If counted in threes, two will remain. If counted in fours, three will remain. If counted in fives, four will remain. If counted in sixes, five will remain. If counted in sevens, nothing will remain. My basket cannot accommodate more than 150 eggs. Can you tell how many minimum number of eggs were there in the basket? So to solve this type of problem, we'll learn the Chinese remainder theorem. And if you have not visited my video based on congruence and modulo, or if you have not learned it from any other source, then please visit these following websites so that you will understand this concept better. Into Great Chinese Remainder Theorem of Number Theory. Let n1, n2, n3 and so on up to nr belongs to natural number be pair-wise relatively prime. For any a1, a2, a3 up to ar belongs to integer, the solution set of simultaneous congruences x is congruent to a1 modulo n1. X can be written as congruent to a2 modulo n2. X is congruent to a3 modulo n3 and so on up to x is equivalent to ar modulo nr. Then it consists of a unique congruence class modulo, that is n is equal to n1 into n2 up to nr. So it seems to be difficult, but while you will solve the problem, it will be easy for you to understand. Now let us go for the steps to find the solution using Chinese remainder theorem. Given x is congruent to a1 modulo n1, again it is congruent to a2 modulo n2, again it is congruent to a3 modulo n3, it may be anything up to r. We will find the value of x. The first step 1 is find n is equal to product of all individual n. Here n1 into n2 into n3. That means we have to express x as modulo n. Next step, we will find each individual n. n1 is equal to n upon small n1. n2 is equal to n upon small n2. And n3 is equal to n upon small n3. Next, we will find x1, x2, x3 from the expression capital N1 into x1 is equal to 1 modulo n1. n2 x2 is equal to 1 modulo n2. And n3 x3 is equal to 1 modulo n3. So after getting x1, x2, x3, we will go for x is congruent to summation of ai, ni, xi modulo n. Here 3 are there, so is equal to sum of a1, n1, x1 plus a2, n2, x2 plus a3, n3, x3 modulo n. I hope you followed the procedure. Next we will go for an example. Let us take an example where we use this Chinese remainder theorem. Or why should we learn it? A number which is divided by 3 leaves remainder 2, divided by 4 leaves remainder 3, and divided by 5 it leaves remainder 4. What is the number? So we will break this statement according to the remainder theorem. X, let the number be x. X is congruent to 2 modulo 3. X is congruent to 3 modulo 4. X is again congruent to 4 modulo 5. So A1 is 2 here, A2 is 3 and A3 is 4. And N1 is 3, N2 is 4 and 3 is 5. So whole congruence will be N1 into N2 into N3, that will be 60. So we will find for modulo 60. Let us go for whole solution of the problem. X is congruent to 2 modulo 3, X is congruent to 3 modulo 4, X is congruent to 4 modulo 5. We have already seen. So A1 is 2, A2 is 3 and A3 is 4, N1 is 3, N2 is 4 and 3 is 5. We have already discussed, and N is equal to 4 multiplies 3 multiply 5, that will be 60. So we will get congruent for modulo 60. So now this is the procedure. We will get capital N1 is equal to N upon N1. That will be 60 divided by 3. That will be 4 into 5, 20. N2 is equal to N upon N2. 60 divided by 4. What will remain? It will remain 3 into 5. That will be 50. And N3 is equal to again 60 divided by 5. It will be 3 into 4, 12. So we will make a table like this: N1, A1 and capital Ni. Now coming to 20x1 is equal to 1 modulo 3. 15x2 is equal to 1 modulo 4. And 12x3 is equal to 1 modulo 5, and we will find the value of x1, x2, x3. So here x1 will be 2, x2 will be 3 and x3 will be again 3. Now we will make a column for ai into ni into xi. So first will be 2 into 20 into 2, that will be 80. 3 into 3 into 15, that will be 135. And 4 into 3 into 12, that will be 144. Now we will take the summation of ai, ni, xi. So it will be 80 plus 135 plus 144. Total is 359. We will find 359 is congruent to what modulo 60. So 359 divided by 60 will get remainder 59. So answer is 59. Solve the system of congruences. Let us take another question. X is congruent to 1 modulo 3. X is again congruent to 2 modulo 5. X is congruent to 3 modulo 7. We have to solve it. Here N1, Ni, 3, 5 and 7. And Ai are 1, 2, 3 respectively. So capital N is equal to product of N1 into N2 into N3, that will be 3 into 7 into 5, it will be 105. Now coming to individual capital N. capital Ni is equal to n upon small ni. So capital N1 will be 105 divided by 3, that will be 35. N2 will be 105 divided by 5, that will be 21. And N3 will be 105 divided by 7, that will be 50. To find the value of x1, x2, x3. Now 35 x1 is congruent to 1 modulo 3. Or if we divide 35 with 3, then 2 is remainder. So 2x1 is congruent to 1 modulo 3. Now x1 will be 2 because 2 2s are 4, which is congruent to 1 modulo 3. Similarly, for x2 we will write 21x2 is congruent to 1 modulo 5. Now 5 4s are 20, so x2 will be equal to 1. Coming to x3, 15x3 is equal to 1 modulo 7. So this is same as x3 is equal to 1 because 7 2s are 14, 1 is left. Now xi will be 2, 1, 1. Next is we will make column for ai multiplies ni multiplies xi. So first row it will be 35 into 1 into 270. Second it will be 21 into 2 42. Third will be 15 into 3 into 1 45. Now we will take the sum. The sum will be 150. Now 157 modulus 105 is congruent to 52 modulus 105 because 157 divided by 105, 52 is the remainder. So answer is 52 here. Now let us come to a word problem based on this. A troop of 17 monkeys stored their bananas in 11 piles of equal size, each containing more than one banana, with a 12th pile of 6 left over. When they divide the bananas into 17 equal piles, none are left over. What is the smallest number of the bananas they can have? So let the number be x, writing as x congruent to ai modulo ni, we get x is congruent to 6 modulo 11 as well as x is congruent to 0 modulo 17. So n is here 11 multiplied 17, 187. So we have to express as modulo 187. So let us make the table. Ni 11 and 17, ai 6 and 0, capital Ni is 17 and 11, xi is 2 and minus 3. So if we multiply ai, ni, xi, first row will getting 6 into 17 into 2, 204, and in second column 0 into 11 into minus 3, that will be 0. So total is 204. So 204 modulus 7, 187. So answer is 204. Now let us get back to our problem. We will count the eggs of woman for which he can demand money. Now solve the system of congruences. X is congruent to 1 modulo 2, x is congruent to 2 modulo 3, x is congruent to 3 modulo 4, x is congruent to 4 modulo 5, x is congruent to 5 modulo 6, and x is congruent to 0 modulo 7. We learned that Chinese remainder theorem is only applicable when n1, n2 or n2, n3 are relatively prime. So here I am selecting the modulo as x is congruent to 1 modulo 2, x is congruent to 2 modulo 3, x is congruent to 4 modulo 5, x is congruent to 0 modulo 7. I am deliberately leaving modulo 4 and modulo 6. Now n is equal to 2 multiplies 3 multiplies 7 multiplies 5 is equal to 210. Find individual n. So total n is 210. So capital N1 will be 210 divided by 2, that will be 105. N2 will be 210 divided by 3, it will be 70. N3 will be 210 divided by 5, 42. And N4 will be 210 divided by 7, that will be 30. Now to find xi, 105 x1 is equivalent to 1 modulo 2. So x1 is equivalent to 1. 70 x2 is congruent to 1 modulo 3. So x2 is congruent to 1. 42 x3 is equivalent to 1 modulo 5. So this is equivalent to 2 x3 is congruent to 1 modulo 5, or x3 is equal to 3. 30 x4 is congruent to 1 modulo 7. So it is congruent to 2 x4 is congruent to 1 modulo 7, where x4 is equal to 4. So xi 1, 1, 3, 4. Next to get the answer, get the product. Now 749 xi. So 105 divided with 105, 70 into 2. So 119 is the 42 into 4 into 3, 500. 119 4 into 0, it will be 0, 10. So total we have verify the answer whether 119 will be correct or not. So we left x is equal to 3 modulo 4. So let us divide 119 with 4 to check whether remainder is 3. We will divide with 4, yes, remainder is 3. Next we will divide with 6 to see whether the remainder is 5 or not. So yes, it is remainder is 5. So 119 satisfies all the conditions. So the answer is 109. So this is a very interesting problem explained in class 10 CBSE book. So we should learn how the answer is calculated. But this is not only the method. We can get also some other method to find the answer. Lowest integer x which leaves the remainder 1, 2, 3, 4 n divided by 5, 7, 9, 11 respectively. So we are asked to solve the system of congruences. X is congruent to 1 modulo 5, X is congruent to 2 modulo 7, X is congruent to 3 modulo 9, and X is congruent to 4 modulo 11. The 5, 7, 9, 11 are prime to each other. So n is equal to 5 into 7 into 9 into 11, that will be 3465. Now n1 is here 693, n2 is 495, n3 is 385, and n4 is 315. Now 693 x1 is equal to 1 modulo 5. So 3x1 is 1 modulo 5. This gives us x1 is equal to 2. Next is 495 x2 is congruent to 1 modulo 7. So 5x2 is congruent to 1 modulo 7. This gives x2 is equal to 3. In the same way, 385 x3 is 1 modulo 9, or this is congruent to 7x3 is congruent to 1 modulo 9. This gives x3 is equal to 4. Now coming to last one, 315 x4 is congruent to 1 modulo 11. This gives us 7 x4 is congruent to 1 modulo 11. This is congruent to minus 4. x4 is 1 modulo 11. This gives us x4 is equal to minus 3. Now filling in the table, we should give the product of ai, ni, xi. First we are getting 1386, next 2970, next 4620, and last is minus 37780. So total is 5196 modulo 3465. Now if we divide with it, we will get the next question from Olympiad. Find the solution to 13x is congruent to 1 modulo 70. Now we will first break 70 as a product of primes. 2 multiplies 5 multiplies 7. So we will break the problem into 3. 13x is congruent to 1 modulo 2. 13x is congruent to 1 modulo 5. 13x is congruent to 1 modulo 7. So here let us take y is 13x. So y is congruent to 1 modulo 2, y is congruent to 1 modulo 5, y is congruent to 1 modulo 7. So what is n here? N is 2 into 7 into 5, that will be 70. Now 35x1 is equal to 1 modulo 2. This gives us x1 is equal to 1. Similarly, 14x2 is congruent to 1 modulo 5. This gives us x2 is equal to 1. And 10x3 is equal to congruent to 1 modulo 7 gives us x3 is equal to 5. Now filling in the table and getting the product of ai, ni, xi, we get 35 into 1 is 35, 14 into 3 into 1 is 42, 10 into 6 into 5 is equal to 300. The summation of ai, ni, xi is equal to 377. So 377 modulo 70 is congruent to 27 modulo 70. So the value of x is 27. I hope you have enjoyed learning. More you solve the questions, better you will have problem solving skills. And if you have enjoyed, please share and subscribe my channel.